Chapter 10, Introduction to Machine Learning. In this chapter, you will learn what machine learning is and some popular machine learning classifiers. We'll also consider a Python machine learning library called scikit-learn. Finally, we'll see a machine learning model code. You can modify the model code for your own machine learning algorithms, and you can compare your algorithms with popular machine learning classifiers quite easily. The chapter is a brief introduction to machine learning. I hope it'll be useful. Let's go to section 10.1. What is machine learning? Most real-world problems are expressed as f of x equals y. Here f is an operation, x denotes the input, and y is the output. Once f and x are known, then getting the output is the simplest task. If f and y are known, then finding the input requires to solve the equation. If x and y are known, then you have to find the operation. But this task is not simple. You can find in most cases only approximated operation. Machine learning is dealing with such problems. We define machine learning here. Machine learning algorithms are algorithms that can learn from data and produce functions, models. Machine learning is the science of getting machines to act without functions being explicitly programmed to do so. There are different types of machine learning algorithms. Supervised learning. Usually, in this case, we are using labeled data set. Unsupervised learning uses no labels, as in, for example, clustering. Reinforcement learning is using a reward system. The most popular type is supervised learning. So we'll focus on supervised learning. Machine learning algorithms are based on a belief, and the belief is the average is correct, at least acceptable. Let's see this example. There was a competition, guess the weight of the ox. In 1907, and there is a county fair in Plymouth, Massachusetts. The questioner is Francis Galton, who is a cousin of Charles Darwin. In the fair, he asked the guests the weight of the ox, and there are 800 people gathered, and out of these 800 answers, 13 were not reliable because the answers can be 0 or infinity or not easy to read. So 13 are excluded, and for remainder guesses, the mean measured to be 1197 pounds. And after that, the ox was on the scale and found the real weight is 1198. So that guess from many people, and the average has only 1 pound error. So if we are using many data set, many data points in the data set, then the average would be correct, at least acceptable. So under this belief, machine learning algorithms have been developed. Here we have supervised learning. The assumption is that for given data set, xi, yi, and yi are labels, there exists a relation f from x to y. So the task of supervised learning is to find the f. So by using a training data set, xi, yi, and we try to get f hat, which is a good approximation to original relation. We don't know this one, so that eventually, once we found a model, found a relation or function, then there will be an approximation to the original relation. Pictorially, we can explain the supervised learning. Training data will be given with labels. By using this data set, machine learning algorithm will make a model. Once later new data points are coming in, then by using that, just a prediction is made. That is pictorial interpretation of supervised learning. Here, as in this figure, and learning is making a model, a function that is like this hyperplane. So once there are two classes in the data set, then try to find a line or a hyperplane such that, and once a new point comes, then now the value can be negative or positive, so that it can be decided. So this hyperplane has the value 0, so that for given data point, negative, positive, then we can decide. That's the main idea of the organizing the model. And also for these data points, we try to find the tendency or trends of data points. There is a kind of a regression. Okay. Unsupervised learning can be used to explore the structure of the data set. And in the beginning, we don't know anything. There's no label. However, once data set is given, then we have to find some hidden structure. That's the purpose of unsupervised learning. In supervised learning, we are using labels, and also in reinforcement learning, we are using some reward system. But in unsupervised learning, we don't have anything. Just we explore the hidden structure of the data set. One example is clustering. In clustering, we try to make the meaningful subgroups. See this example, the figure. And there are 3 groups of points. This one, ideally, is working very nicely to get meaningful subgroups. Okay. So it looks, the idea of machine learning is simple, but in reality, the machine learning is not really simple. why is machine learning not always simple? In algorithm, in training, the overfitting, the first issue is overfitting. This one can happen quite easily. In training, we try to train the data set too tightly. For example, here we have two parts in the data set. In this case, the fitting is too rough, and for that one, it is fitting too tight. So, for example, if there is a point, for example, and easily you may assume that there must be some point here like that, so around here like that. Then if you make the model too tight, then for new point, it can be predicted wrong. So that is called overfitting. So it can happen quite easily. So that the problem is the accuracy drops significantly for test data. Once new point comes, then accuracy is quite poor. But for given training data, the accuracy is really good. In this case, for the training data set, its accuracy is 100%. But for new data points, the accuracy must be much lower than 100. Okay. To overcome this issue, we may try to use more training data, but in reality, it's often impossible. Training data means money. Some people pay the money to get data set, so that more training data set means requiring more experiment and more data acquisition. And at the moment of training the data set, it's impossible to get more training data. And when you train the model, usually the algorithm is iterative algorithm. So you may try to stop early, or you may try to select some important features so that try to reduce the dimension. Or you may add some regularization term for your objective function, or you may try to use multiple classifiers, and the outputs can be used to get majority vote. These are remedies, but overfitting yet happens quite frequently. Curse of dimensionality. The feature space becomes increasingly sparse for an increasing number of dimensions. See this figure. Once we consider the data points in one-dimensional space, then it looks dense. But in two-dimensional space, as they are apart. And then in three-dimensional space, looks like the data points appear equidistant, and every points are far away each other, so that machine learning algorithm can be very hard to recognize groups of points. In most cases, even though it is a supervised learning, the model is based on groups of points in many cases, so that once it is happening, then the accuracies are very poor. So that phenomenon is called curse of dimensionality. To overcome, you need basically more training data. Again, is often impossible. And another one is dimensionality reduction. by using feature selection, you can reduce. Just try to select only important features, then maybe better. And or by using principal component analysis, you may try to transform the data set into orthogonal space and then try to select first several principal components. Then your dimension is reduced. So maybe the cost of dimensionality will be decreased. Now, most algorithms are based on objective function. This objective function may have multiple local minima. If you are using gradient descent method, then it can convert to local minima. For example, in 1D figure, the object function may have object function like this, like that. If your initial value start from here, then it will convert it to this point. If you start from here, it will go over there. So, but in the beginning, we don't know where the global minimum is. So that depending on your choice of initialization, the model can be quite different and produce sometimes larger error. Anyway, it is not repeatable. And to overcome that problem, we may try to get Gaussian scaling or regularization. Gaussian scaling means that try to make some smoother objective function so that after finding this minimum, by using this one again, try to use less the smooth one again, and then eventually we try to use the original object function to get its global minimum. But also it is not easy to do that. Sometimes we may try to access the data set quite carefully. One of the technique is mini batch. Rather than using all data points, the parts of data points will be accessed in each iteration. In this case, with a smaller number of data points, the objective function is less oscillatory, so that you can achieve the global, you can get the global minimum more likely. Okay. Now, fourth issue is interpretability. Although machine learning has come very far and very successful for some application areas, and researchers still don't know exactly how some algorithms work. That is, one example is deep networks. Once you don't know how it works, then how do we make any real progress? So that we have to understand and we have to be able to explain our algorithm, and so that we can modify and we can overcome drawbacks to get better algorithms. So interpretability is a hard issue. And in modern term, it is called explainable AI, XAI. That is a hot topic in the current machine learning society. And finally, we have an issue around data size for learning. And we still haven't been able to achieve one-shot learning. Traditionally, gradient descent method for neural networks need a huge amount of data. And then also often we need very many of iterations for training. But human intelligence can understand the object with a few of examples. So the question is, can we make any machine learning algorithm such that it can be trained using just a few the samples? That's the question. If you can solve this issue, then you can be a billionaire very quickly. Okay, that's the end of the section. Thank you.